The advantage of using a closed form solution is we are always guaranteed to obtain the value of the parameters at the minima of the sum of squared errors function. But the disadvantage, as we have already discussed, is it cannot be used for other kind of models. It can only be used for a model which is similar to linear regression. So now let us talk about how gradient descent approach works. So in gradient descent approach, what we do is we first of all assume value of the parameter on the function that we have at our disposal. Once we do that, we calculate the value of the gradient at that particular point. If the gradient is not equal to 0, then what we do is we step down from that particular value of the parameter that we have assumed earlier. We step down by a certain amount. This amount is determined by a parameter that we call as step size, and the direction in which we are going to step down is determined by the slope of the curve. So by the gradient descent approach, again we are in an iterative manner trying to reach the minima of the function, and at the minima of the function we are trying to determine the parameters. Here it is important to understand that if the value of learning parameter is too high, then we are going to bounce around the function and we won't be able to reach the global minima of the function. But if the value of learning parameter is too low, in that case we would be stuck inside a local minima and we won't be able to reach to the global minima of the function.